Hey, Esther, parallel and perpendicular lines. I love this stuff. And I want to just give you a quick recap. You are correct when the slopes are equal, slope equals slope, then lines are going to be parallel because they have the same tilt. If they have the same tilt, they have the same slope. Perpendicular lines, the slopes, as you notice, are opposite reciprocals. In other words, slope times slope equals -1. There's only one exception to that perpendicular rule, and I want you to know it because often on SAT and ACTs, they will use this one. A completely vertical line is undefined. Completely horizontal, wow, that doesn't look horizontal. Completely horizontal line is 0 slope. So of course, a completely vertical and horizontal line are also perpendicular. That would be the one exception to the rule. So taking a look here, I can see that you were taught to use what's called the point slope equation of a line, which is y minus y1 equals slope x minus x1 in order to find and then change it to y equals mx plus b form. I'm going to show you a different method using the slope-intercept form. So I'm going to do all 4 of these problems, the 2 methods you have here. Let me just point off right off the bat, you did make one mistake right here. When you distribute things, Esther, I always want you to get in the habit of physically drawing the distributive lines, because right here you failed to distribute to that second term. Okay, so it's really, really, really important whenever you distribute something, even when it's an easy distribution like this, always take the time to circle and draw the distribution, because you did it correct 3 times, but this 4th time right here you dropped it. So just get in the habit of drawing the distribution lines. So I'm going to redo these problems a different way so you can see a different method. Okay, step number 1. You were told that we want to go through this point. So the point is going to be -1, 3. What's really nice about these, it's nice to graph them because it's really easy to see if you're correct if you graph them. So -1, +3 is right here. -1, +3. So that's the point we want to go to. We want it to be parallel to this line. So let's just graph that line, where it's going to be at -1, and then our slope is -3 over 1, so we're going to go down 3 over 1, up 3 over 1, so here we are, and the line's going to be right here. Going through that line. All right, now we want it parallel, which means the same slope. So you correctly put that here, and then you put the point where it belongs. Y minus y1 goes there, and x minus x1, and you correctly swap the signs. So what you did here was absolutely correct. Let me just show you another way you can do this. So another way is to use y equals mx plus b. And in this circumstance, your slope is the desired slope you want, which is parallel. So I'm going to put a -3 here. And then we're going to solve for the y-intercept by putting this value of x right in the x-coordinate, this value of y in the y position, and then we're going to solve for the y-intercept. So this is 3 plus b, and of course minus 3, and you solve. Our y-intercept is 0, which is what you got here. So y equals negative 3x plus 0. So this would be our second line. So we start at 0. And our slope is negative 3 over 1 again. So up 3 over 1. You can see we're going to go right through that line, down 3 and over 1. And when you graph it, it does exactly what it describes. It's parallel to our given line, and it goes through the point that we wanted it to go through, which was negative 1, 3. So your method was correct, and then I showed you a secondary method. So I'm going to show you both methods for all 4 of them. Okay, so for this one, we want it perpendicular. So the first thing is that you correctly needed to change that to y equals mx plus b. So I'm trying to see what the original was here. Esther, you might want to next time take your pictures so that it's like straight down. It's a little hard to see that at an angle. Let me see if I can't see the original problem here. What was that original problem? Okay, that's x plus y equals negative 1. X plus y equals negative 1. Okay, so you minus x, so we end up with y equals negative x minus 1. That's fine. So that you end up with your slope is basically negative 1 over 1. Okay, so our current slope is negative 1 over 1, which means our perpendicular slope is going to be positive 1. And you correctly put positive 1 there. You correctly put 4 there. And 3 there. Okay, so your method was correct. Let me just show you my method so that you can see how you're going to end up with the same thing. So I'm going to do y equals mx plus b. And in this case, I'm going to take that x, I'm going to put it right here, that's 4. That y, which is 3, and then my slope is going to be a positive 1, and I solve for the b. B equals negative 1. So this line is going to be y equals 1x minus 1. So now let's graph both lines. It's always important that you see these so that you can see how they work. So let's graph this first line here, which is at negative 1. Then it's a negative 1 over 1 slope. So it's down 1 and over 1, up 1 and over 1. So there is your original line. Okay. And then we're going to graph this line here, our desired point was 4, 3. So let's plot that point. That's 4, 3. Let's see if it works. So our secondary line, we want it perpendicular and going through that point. So we're going to start at -1. And it's positive, up 1 over 1, down 1 over 1. And you can see that, yes, we're going through that desired point, and it is perpendicular. Alrighty, let's take a look at your math here. So you want to change that to y equals mx plus b. I'm just going to confirm. So you have positive 2y on both sides. Good. And then we divide by 5. So you end up graphing, or should have graphed, y equals 2/5 x minus 2. All right, let's start by graphing that. You should always have graph paper to check these. It's very reassuring when you graph these problems and they actually fit the descriptor. So here we are at -2. It's a positive line, up 2 over 5. Down 2 over 5. So this is your given line. Okay, and our two conditions, we want it to be perpendicular and go through. There's our target point, +2, -3. So +2, -3, that's our target point. And we want it perpendicular. So this is one where you made the mistake because you didn't distribute that. And I can understand why maybe you are hesitant, because you end up with a mess potentially of fractions. So let me show you my method, and we're going to use y equals mx plus b. You ready? Okay, step number 1, we're going to put the perpendicular slope right there. And our perpendicular slope is going to be -5 over 2. Our x is going to go right there. That's positive, and because I'm dealing with a fraction, I'm going to make this a fraction. That -3 is going to go right over here. And I solve. All right, these two cancel. So I end up with -3 equals -5 plus b. B equals -2. Oh, +2, excuse me, that 5 is bigger. +2. So your secondary line is going to be y equals -5 over 2 x plus 2. Let's graph that and see if it actually works. So we're at +2, and we're doing -5 halves. So up 5 and left 2, or down 5 to the right 2. And you can see right there we hit our target right on the money here. All right, now just so you can see your method, it would have worked let me show you what your method would have been. You're working with what's called point slope form. So your method would be like this. Y minus y1 equals slope x minus x1. So in this case, your slope that you wanted to work with is negative 5/2. And parentheses x, and your x1 is positive 2, so that would have been minus positive 2 right there, equals y, and it's minus negative 3. Okay, we're going to distribute. And I end up with y plus 3 equals negative 5/2. And then when you distribute, negative 5/2 times negative 2, these cancel, and this ends up being plus 5. And now we're going to go minus 3. You end up with y equals negative 5/2x plus 2. So you can see you do get the exact same method using point slope as you do y equals mx plus b. So you need to decide what is your teacher requiring you to do, and then which one makes more sense to you, because both methods obviously work. Okay, one more problem here. Can't really tell what that original problem says. That number's getting cut off. That looks like a 2. Let me see if I can't go to the original. Nope, it's cut off for both of them. Hang on, let me try to find it here. Is that a 3? I think it's a 3. Think it's a 3. Let's go ahead and pretend it's a 3 and see if it works. Okay, so we have positive 3 here, 1, 2, 3, and we are graphing negative 3/4. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. Okay, this is your given line. And we want it parallel, so we want the same slope, which is negative 3/4. Okay, so I'm going to show you my method. I'm going to do y equals mx plus b. So our slope is going to be exactly the same, negative 3/4. Our x is positive 1. Our y is negative 1 plus b. We solve. Of course, this is negative 1 equals negative 3/4 plus b. I'm going to add 3/4, add 3/4. And this ends up being, this is technically negative 1 is technically negative 4/4. So our b equals negative 1/4, which is, you have 3/4 there. Let's figure out why. Okay, so right here, Esther, this is the little trick. I think that's where you got lost. Let me take this in the margin so you can see your work there. Okay, so you had, let me just take this little caret here. I'm going to do this in green. Right there, you had 3/4, but it was minus 1. The trick here is that this was a fraction and this is a whole number. So in order for you to work those, technically it's like this. It's 3/4 minus 4/4 because you had to get your denominators the same, which would have given you -1/4. So your y-intercept, or your b, should be -1/4, which I have down here. So here's your final version. Y equals -3/4 x minus 1/4. So we're going to come up here. Let's plot our target point, which is 1, -1. This is going to be a very fine plot here. 1, -1 is right here. And yeah, 1, -1 is right there. We are doing -1/4 and then -3/4. So I'm going to have to make this really big for you to see. Got it. So 1/4, -1/4, correct? Yeah, -1/4. So you got to imagine that little thing here. I'm going to have to get real small. Is 1. Oh, that's even too big. There's half. So we've got 1, 2, 3, 4. So our fourth is going to be about right there. And then we are counting a slope of -3/4. So from right here, -3/4. That is going to be down 3/4. So right here, that 1/4 to 1/4, that's 1, 2, 3. That's 3 units at the 4th. And then we go over 4, roughly. 1, 2, 3, 4. This is not very precise there. Okay, and we're starting at this point because your intercept's right there. I'm going to do this in green so it's easy to see. And when you connect them, lo and behold, you actually do hit your point. And it is parallel. There it is. Now that one was a little bit tricky, so you need to watch out right here, Esther, when you have a fraction and you're minusing a whole number right here, you needed to change that 1 into -4/4 so that it matches the denominator of 3/4 right there. That was the trick to that problem. You have to be really careful with fractions. I hope this was helpful, Esther. I'd be happy if you have more of these problems you'd like to go over this weekend, Saturday or Sunday, and you'd like to do a live Zoom session so we can interact. I'd be happy to do that, my dear. I'm going to send this to you on Facebook. Hope you're doing well. Give your mom and dad a hug for me.